We're going to call this amazing handwritten page the 2.3 Day 3 warm-up.
It's a complicated name.
Well, and the font that I used on the computer was amazing. Okay, so it was called McCoy handwriting font. So we went with that today. All right. So it says identify the axis of symmetry, vertex, focus, and directrix. A picture may help. Now, when I say a picture may help, I'm talking that a quick sketch. So maybe thinking a sketch may help. So when I'm looking at this problem and I say x equals 1/16 times quantity y minus 3 quantity squared plus 1, I am going, dude, that's an x equals. It's a positive a term. That means my graph is going to look like that. Okay? That's what I mean by a picture, a quick sketch. Because we're going to use that picture. As amazing as it looks, we're going to use it quite a bit. Okay. So, first thing I'm going to do is I'm going to figure out the axis of symmetry, which happens to run this way. And a line that runs horizontally, is that a y equals or an x equals? It is a y equals. Y equals, and in this case, in order to find out the axis of symmetry, we would have to identify our k term, usually. However, when it's an x equals, our y's deal with this part. It's backwards. Yeah.
It says describe the transformation of the graph of the standard equation with vertex 0, 0, and p equals 1. So
yeah. Right. We're gonna go. Let's use this for right now. Okay. So we're gonna work through these problems here. All right. And this will actually answer that. It's using the same stuff. Okay. So this. My y equals, it's y equals 3. Okay? My vertex, when I have an x equals graph, my vertex is still an xy, but my y is inside here, and my x is outside here. The x's are on the outside, the y's on the inside. It's backwards. Okay? So this is 3, and this is 1. Okay. You guys with me there? All right. Now, so we have our axis of symmetry. We have our vertex. Our focus. Well, when we're dealing with the focus on it, our focus is a coordinate as well. And our focus lies on this line, just like the vertex does. The focus actually moves inside a certain distance inside the parabola. So since it's on that line is called what? Axis of symmetry, and what's the name of this axis? Y equals 3. Question? Okay, can we hold on? Just, like, if it's actual question, give me 1 second on it, okay? Now, give me like 30 seconds, because some people actually count to 1. Maybe like 2 minutes. There you go. Count to 120 in seconds. Okay, so Chase, you said that this line is called, and what's the equation? Therefore, the focus is in that same y equals 3. So the y value is 3. Okay? Yes?
Wouldn't it be 6?
It would not be 6. No, my y value hasn't changed. My focus is right here. Y is still the same.
Yeah, but isn't it based off from the vertex?
It is. Yeah. But the y value has not. The x value, it's going to move horizontally. It's not going to move vertically. Okay?
Oh, yeah.
All right. So now, if I come back here and I go, look, I know that my a term right here, so that I can actually find this, I need to know what p is. I know my a term is equal to 1 over 4p. And so that means 16 equals 4p, or p equals 4. Which means that I can take this 4 and I am adding it to my 1 right here. I am moving that far from my vertex. I'm going 4 units, which is 5. Now my directrix, I'm moving the opposite way. It's this line. Okay? And I went 4 units this way. I'm going to move 4 units this way. Therefore, I am subtracting 4, which gives me... So if it helps you, maybe put it up here and say, well, I subtract here. Okay, I'm subtracting. That's actually going to give me negative 3. Now, is that an x or a y equals? Yeah, this is an x equals. X equals negative 3. Okay, if you want to put it down here so it's not cramped, that's fine as well. Okay, but to find the focus, you add to it. In this case, you subtract from it to find the directrix. You're changing horizontally, therefore you're changing your x value. So you got your focus, your directrix, and your vertex, and your axis of symmetry. Okay, that was more than 120 seconds, Riley, but go ahead.
Maybe easier, could you think of it as like the same as a normal graph, but think of it as x as the x-axis as the up and down, and y as like the left and right?
You could, and if that works for you, that's great. I don't think that would make it easier for a lot of students there. Okay, when you're, and if it does, fantastic. But if you start switching your axes around, I think that makes it a little more complex because you're still dealing with x and y, right? I mean, when you switch your axes, how are you determining that your y? I mean, you're thinking of it like this, right? You're saying this is y and this is x. Okay, but when you're dealing with this equation, or excuse me, this expression in here, you're still shifting this way. Or excuse me, yeah, you're shifting this way then. I think that would mess with my mind. But if that works for you, then use it. Did it give you the correct solution? Okay, fantastic, then use it. I'm not going to go through it that way though. Okay, I want you guys to try number 2. Give it a go. Okay, picture, is it opening up, down, left, or right? Opening to the right. Okay. And in terms of our axis of symmetry, the line goes this way. It is a y equals -7. It's in there with the y. I'm going to leave a spot for my directrix. I have my vertex. Okay, as far as my vertex goes, we know what y is. And x is -8. Okay, and then I have my focus. In order to get the focus, I have to do So 8 equals 4p. So p is 2, meaning I am moving this way 2 units, meaning I'm adding 2, which gives me -6. Okay? And then my directrix, I'm moving this way 2, meaning I am subtracting 2. -8 and -2 is -10. And that is -10 equals x, or x equals -10. Okay? All right. Please note that this value right here, once you find the axis of symmetry, it tells you these values. Those are all the same. They're on the same line. Your focus, your vertex, all lie on the axis of symmetry. Okay? How many got it? We good? Okay, challenge you. There you go. Might be a little challenge. Yeah, I know. No, I did that. All right, this picture opens. It opens to the left. Therefore, my vertex there, axis of symmetry is still a y equals. It's y equals 2. The vertex, we know our y value is 2. I didn't leave room for my directrix, so I'm going to put that right there. Okay, which we'll get here in a minute. And then my focus, we'll have to figure out as well. But we know this is 2. All right, so now we do finishing up the vertex. That's 1. And we say 1 over -12 equals 1 over p. -12 equals 4p, so p is -3. Now, it does not mean, when we're dealing with this, it does not mean we add a -3. We are moving to the left 3 units, meaning from 1, we're moving that way 3 units, so we are subtracting 3 to get to -2. That is the focus. Okay, we are moving to the right, how many units? 3 units to get to the directrix. So we move this way 3 units. So that length is 3, that length is 3. We move that way 3 units, which means we add 3. The directrix is x equals 4. 1 plus 3 is 4. How many got it? Well done. Hey, the picture will help you out a bit. Not an amazing picture. It's not an amazing artistic work, but all right. Any questions? Okay. So Riley, I'm going to come over and you're going to explain to me how you're switching those and making it sense in your head. Okay? All right. Very good.